solve this question. In this question it's been asked that two organic compounds X and Y containing carbon and hydrogen only have vapor densities 13 and 39 respectively. State the molecular formula of X and Y. Okay, so let's understand this question. This question is first of all little bit tricky because it says that there is two organic compounds X and Y containing carbon and hydrogen only, and it is given the vapor densities of both the compound X and Y, which is 13 and 39 respectively, and they are asking us to find the molecular formula of X and Y. Now you would say that it's simple, molecular vapor density is given, so 2 into vapor density is molecular weight. Here it's molecular weight, and we have to calculate the molecular formula. So let me explain you how can you calculate the molecular formula in this type of question. So first of all, I'm going to solve for the compound. X, okay, and afterwards we can solve for the compound Y as well similarly. Okay, so let's see. First of all, let me calculate the molecular weight as its vapor density is already given. So molecular weight is nothing but, sir, 2 into vapor density. Vapor density of the compound X is given, which is 13. So 2 into 13 is equals to 26. Simple? Yes, simple. Till now it's simple. Okay, now one important thing over here which is mentioned in this question, it says that carbon and hydrogen only. Okay, the organic compound X and Y containing carbon and hydrogen only. That means no other element than the carbon and hydrogen is present in the compound. But the problem is we don't know whether the it is C2H4, whether it is C2H3, whether it is, no, it could be C2H3, C2H6, or whether it is CH4. We don't know that what is the value of this over here, how many carbon is present in it, how many hydrogen present in it. Okay, that we don't know, but we know that is only carbon and hydrogen. So let me write down the molecular formula. Compound X is equals to CaHb. Assume it's CaHb, where we don't know the value of A and B, and that's what we have to calculate. If we know that A and value of A and B, then it would be our molecular formula which we have to calculate. Okay, but sir, how can we do it? So it's very simple. We know the molecular formula weight. Yes, the molecular weight is 26. Okay, so we have to substitute this value of A and B in order to get the exact value as a 26. Okay, so how can we calculate the molecular weight? So we add all the elements present in the compound. Okay, so if I say A into carbon plus B into hydrogen, am I right? That's what we do. A into carbon, B into hydrogen. Let me give you a simple example. If my compound is CH4, what I'm going to calculate, how will I calculate the molecular weight? So 1 hydrogen, that means 1 into carbon, plus 4 hydrogen, that means 4 into hydrogen. Okay, so carbon is 12, so 1 into 12 plus 4 into 1, it would be 12 plus 4, which is nothing but 16. Correct? This is how we calculate. So that's what I have done over here. Instead of putting any numbers, I have done the A and B. Now I'm going to substitute the value of A and B, and I will see if I get the 26. Okay, so if I put value of A is equals to 1 and B is equals to 1, first of all, the carbon is 12, so A into 12 plus B into 1. Okay, so what should I put the first value? 1 1. So if I keep the value as 1 1, answer is gonna be 13, which is not matching, so 1 is not the answer. Second, if I put the 2 2, okay, so it would be 12 times 2 would be 24 plus 2, which is nothing but the 26. So yes sir, value of A and B is 2. So that's the only time we get the value as 26. Okay, so the molecular formula would be C2H2. Okay, C2H2. Now let me explain you how we solve this type of question. So first of all, they were asking us to calculate the molecular formula, and only the two informations were given, that the compound contains only carbon and hydrogen and its vapor density is 13. Okay, so what do we do in this type of question? First of all, we calculate the vapor density. So first we calculate the molecular formula by multiplying vapor density by 2. So we got the molecular weight is equal to 26. Now we know that compound contains only carbon and hydrogen, but we don't know how many carbon and how many hydrogen will be present in the one compound. Okay, so instead of putting any number, we wrote over there arbitrary constant A and B. Okay, so let's suppose CaHb is equals to 26. That is, total molecular weight is 26. Though just we have to calculate the molecular weight and we have to substitute the value of A and B in order to get the 26. So this is basically a trial and error method kind of stuff. So where we substitute the different values of A and B and we try to find the value of, we try to match the value is equal to the molecular weight. Okay, now one more thing is still remaining, which is the compound Y. So let's try to solve the compound Y as well. As you know now how we calculated X, so we can solve for the compound Y as well. Okay, so we're gonna go for the compound Y. Okay, again what do? First we calculate the molecular weight. How we gonna calculate molecular weight? 2 into vapor density. Vapor density over here is 39. Vapor density over here is 39. So molecular weight is equals to 2 into vapor density. What is vapor density? So 39. Okay, so when you multiply 2 into 39, you get the answer is equals to 78. Okay, now again it says that this compound has only two elements, carbon and hydrogen. Okay, that means we know that compound is gonna be either compound has carbon and hydrogen, but we don't know again the value of this A and B. Okay, so what are we gonna do? We're gonna substitute the value A and B. As we have already used A and B, so let me explain C and D. Okay, so I can use carbon as C and hydrogen as D. Okay, CCHD. Okay, so compound Y is equals to CCHD. Now if I want to calculate the molecular formula, I know the molecular weight, so this would be equal to 78. Now I am gonna substitute the different values of it and I will try to find the value which matches the my molecular weight. Okay, so molecular weight is equals to C into 12 as a carbon plus D into hydrogen. Hydrogen is 1 over here, which should be equal to 78. Okay, it should be equal to 78. Now if I put the value is equals to 1 at both the side, so it is gonna be, and it's 78, it is gonna be only 13, so it's not right. Okay, so 1 is not the answer. What if I put the 2 at both the sides? So it's gonna be 24 plus 2, which is nothing but 26. So 2 is also not the correct answer. What if I keep the 3? 36 plus 3, which is gonna be 39. So it's not correct again. So over here, if you put both the side 4, it's gonna be 48 plus 4, which is gonna be 52. Again, not right. What if I substitute both the side by 5? So it's gonna be 60 plus 5, it's gonna be 65. Again, not right. What if I substitute both the value as 6? 72 plus 6 is gonna be 78. So if I substitute both the side by 6, then I get my value is equal to 78, which is matching over here. That means my molecular formula is molecular formula is C6H6. It could be benzene. Just a thing, it could be C6H6. So what do we do in this type of question? Again, first of all, we calculate the molecular weight. Then, as we know that it only has carbon and hydrogen, but we don't know how many carbon and how many hydrogen is gonna be in the one formula. We know the molecular weight, so we're gonna calculate the molecular weight, and we're gonna put the different values of C and D in order to match the molecular weight. Okay, so once the molecular weight matches, that C and that value of C and D would come in my molecular formula. Okay, so if you still have any particular doubt regarding this question, or if you have any other question in your mind about this type of questions, then you can comment your doubt into the comment section. We'll try to make a dedicated video towards your doubt. Till then, keep on studying.